So let's take a look. It says, in the diagram, PQRS is a quadrilateral with diagonals PR and QS drawn. W is a point on PS. Okay, that's just saying that they've randomly plotted a point along the side here and it sits at W. WT is parallel to PQ. Okay, very important, with T on QS. Secondly, it says WV is parallel to PR with V on RS. Okay, so when they say with V on RS and T on QS, it's just saying that we have lines that are parallel and there are points on the sides that make them parallel. TV is drawn, that is just a line, okay, and then it says that the ratio of PW to WS is 3:2. Okay, remember that ratio is simplified. There is a common factor in those sides there. Okay, so before we even go into the question, guys, identify your triangles. So this triangle over here, QPS, okay, this is the side or the length that is parallel to the third side. Okay, so remember that means that the proportions are the same. Okay, I'm using different factors every time because we don't actually know the lengths of those sides. Okay, but then also, guys, there is another triangle. If you look over here, we've got this triangle PRS, which also features parallel lines, except we've got WV being parallel to PR. Okay, so that means that this ratio here also applies to these sides. Okay, very important. So over here we've got another 3:2 ratio, and I've put the constants in because we don't know the actual lengths. That is just a ratio. So guys, use colors. Make your diagram colorful so you can understand what they're asking. So now it says, question 1, write down the value of the following ratios, ST to TQ. So let's take a look here. ST is part of the yellow triangle, sits over here, and TQ is over there. So now if you filled in your diagram, you know that ST to TQ is 2:3. Same as that initial that we did over here. Okay. This gave us the yardstick by which we can measure all the other ratios. Then it says, find the ratio of SV to VR. Okay, that is in our green triangle. Now because there is a parallel line coming from W and it is still this ratio over here, guys, it is still the ratio that we're dealing with. So SV to VR is also 2/3. Then it says, question 2, prove that T1 is equal to Q1. So let's take a look. Where is T1? Okay, T1 is over here and Q1 is over there. Okay, so now if we look, I'm going to redraw that triangle QSR. Okay, that's this triangle coming from Q, going to S, and then ending up at R. Q, S, R. We have established that they drew this line. They drew the line TV. Okay, so we've got TV over here. TV. And we're trying to find T1 that sits over there and Q1 that sits over there. We have established in previous questions that ST to TQ is 2:3. Okay, we've established that. I think it was the first question. ST to TQ, 2:3. And then in the second question, we also established that this is 2:3. We said that this was P. And then this over here, we used K. 2K to 3K because they were part of different triangles, but they had the same ratios. So now if I can say ST to TQ, ST to TQ is equal to SV to VR. We've proven that. We found that these two ratios are the same here, these ones over here. Okay? If I can say that these ratios are the same, it means that their sides are in proportion. Okay, so therefore, sides are in proportion. And what does that mean? Remember, guys, if I give you a triangle and I say, okay, cool, I'm drawing this line here that is parallel to one side, it divides these sides in proportion. Now, we're going backwards. We're saying that I've given you that the sides are in proportion, and therefore you can make the conjecture that these two are parallel. Okay, so let's take a look here. In our triangle, it means that because those sides are in proportion, these two sides are parallel. TV is parallel to QR. Therefore, TV is parallel to QR. And give a reason, guys. Sides in proportion. Okay. Why did we establish this parallel relationship? Well, now, if we look at our triangle over here, if we have a transversal cutting parallel lines, we know that the corresponding angles are equal to each other. So let's take a look. Therefore, T1 is equal to Q1, and your reason is corresponding angles, and give your parallel lines so that your examiner knows where you're talking about. Okay, always treat your examiner like they have no clue. Question 3 says, complete the following statement. Triangle VWS is similar to what triangle? VWS. Okay, VWS, let's try and get another color going. I'm going to go over it in white again. VWS is this little triangle here. Okay, so if you look, we've got parallel lines, so corresponding angles over there and corresponding angles over here. Okay, so remember, similar triangles have corresponding angles. Luckily for you, you don't have to prove them. You don't have to list the angles. You can just say that VWS is similar to triangle RPS. VWS is similar to triangle RPS. Okay, and you could say that they are equiangular. But it doesn't say prove, it just says complete that statement. So if you just say this, that is 100% fine. And lastly, it says determine WV to PR. WV, okay, I'm going to use blue and hopefully it doesn't make a mess. WV to PR. Okay, so remember, we've established, let me get rid of this diagram. We've established in our previous question that over here we've got PRS as the big triangle. Ooh, whoopsie daisy. S is over there as the big triangle. And then we've established that this line here is parallel, and so these triangles are similar. Okay, and we're trying to find, let me just double check, WV over PR. So WV, look at me, this is supposed to be a V here. WV is that length there, and PR is the big length there. Okay, so in order to do that, remember we established that this is 3x and this is 2x. So if I want to take a short side over a long side, I need to relate it to another short side over a long side. So this is the short side, and that is the long side. It is the whole side. So I'm going to do the proof here. WV to PR is equal to WS to PS. Okay, and the reason is line parallel to one side, which means that it is equal to WS, we said was 2x, and PS will be the sum of those two sides, which is 5x. So that means that this whole ratio that we need to prove here is equal to 2 over 5. Okay, make sure you understand what they're asking you guys. Short side, long side. Short side, long side. Okay, so guys, when you are dealing with this kind of thing, establish where your parallel lines are and make sure you understand which triangle they fall into. That's how you understand your proportionate sides, okay? Make sure you see parallel line parallel to this side of the triangle, which means those sides are in proportion, okay?